This is then part 4, I guess. Let me just go to the producer and start the session. Create broadcast. Learning how to code a Solana trade bot. Part 4, technology, OBS. All right, cool. So I'm just getting these started right now. I am going to post about these. There we go, part 4. Perfect. So, don't tell me baby was crying now. No, I think it was good. I think it was good. Okay. So, okay. Muting myself. Perfect. We got it. All right. We're continuing with our Solana session. Yeah. So now we did blockchain basics. We did wallets and transactions the other day, which I'm not so sure I don't think we've finished all of it, but I'm kind of like hopping a bit here and there. I do have the need to get a bit more hands-on with actual coding or understand maybe a bit more of these. I'm like, that's how I am. I kind of like hop on and off. I don't know, that's with the wallet and transactions. We learned about the way that the public keys and the private keys and the wallets and all this kind of stuff works. But we didn't learn about transaction making, so maybe that's something worth continuing. And today I'm feeling Piotr Binkowski again. Yeah, we should kind of jump to that. I hope that the session doesn't have the bug and it remembers that I actually finished that one step. If not, we'll actually mark it down now, if I can mark it down. And if I cannot mark it down, we will just skip it. We will just skip it. Well, we did talk about the transaction stuff, right? Yeah, chapter 1 was completed. How do you write about the wallets? Chapter 2 is write down different key differences between a hot wallet and a cold wallet, including one security example from each. What do we have else? Interact during a simple transfer. Okay, maybe we don't really need to learn all that. Let's summarize what 5 transaction gets from creation to confirmation on the network. I mean, okay, this one kind of could be useful. Basic transaction using a wallet. But I somehow I'll get to these. I think I'll go back to dashboard. And actually that should be back to the plan, by the way. I'm gonna start on the mechanics. Radium and Jupyter pools work to power your bot's token swaps. I think I want to get into these because I don't really know much about what these swaps. And you know what? Yeah, no, we'll do Piotr. Because I don't know much about that. This is completely new land to me. Like the concept of swaps and what Radium is and what Jupyter is and all this kind of stuff. So this is definitely going to be an interesting topic to go through. So as you can see, I mean, I'm a grown up enough. I don't have to actually go and do everything in depth. I'll go back to those and complete those sessions eventually. But let's stick to this one. So, all right. So, what do you recall about how decentralized exchanges differ from centralized ones, and why liquidity matters? Oh boy, that's a complicated question. By the way, now we have Grok and Grokipedia, so we actually can jump into Grok and do some deep dive in here. I should make that wider. Sorry, I'm just, again, as usual, use better real estate in here. Make that more responsive. The box is wider, like 90% or something. All right, cool. So decentralized exchanges and how they differ from centralized ones. Let's focus on this one. A decentralized exchange is an exchange where there's a centralized exchange is where you have an entity that basically is the central entity, and it decides what is the valid transaction and what not. And the decentralized is where you just basically have some kind of voting mechanism, right? So you have all the nodes in the network, or some nodes in the network doing some voting, which we kind of really discussed 2 sessions ago, I believe. I'm thinking we don't need an initial probe. I think the session plan is enough of an initial probe. You know what I mean? It's confusing because it's 2 questions at once. Where nobody helps when there's a valid activity, that voting idea fits blockchain consensus. Yeah, most DEX swaps run differently once the chain confirms the transaction. How do you picture the actual price of a swap getting calculated if no one is matching orders or voting on each trade? I mean, isn't that what the liquidity pool is for? I remember reading something like this, that the liquidity pool is exactly what determines the price, actually, not the actual demand. You see that the liquidity pool set the price rather than a live order book. That's the core shift in an AMM. So I'm not so sure what an AMM is, but this the thing is, Sonic, as I was reading about this, so I think what's happening is, in a liquidity pool you have a special token, right? And that token is a token that kind of represents the pair that is being exchanged. And so when you're making a swap, I guess that's what defines it, right? How much of this token is left, kind of, in the liquidity pool. The LP token is a thing whose balance directly sets the swap price. When a swap happens, what actually changes inside the pool? The 2 reserve tokens, or the LP tokens, and which one moves the execution price. No idea. Actually, I need a... I need a copy here. Button. Because what I want to do is I'm just gonna jump to Grok now. So I'm gonna jump off to Grok and ask it this, basically. Okay, so swaps adjust the two reserve tokens balances. Oh, it's thinking. It's thinking through. Okay, so it actually moves inside the pool during a swap. User sends input token, 1000 USDC, to the pool contract. The pool calculates the output amount using the current reserves and the constant product formula or whatever invariant the pool uses. The pool updates the reserves. Reserve USD or reserve WTH increases because you've given it, and decreases. Okay, so the user receives the output tokens. LP tokens are untouched, really. The total supply of the LP tokens remains exactly the same before and after the swap. The spot price before the swap, after the swap, because the reserves have shifted, the price has moved. That is what creates slippage. Larger trades move the reserves more. It's literally as simple as this division. What is the purpose of the LP and the LPA token if it doesn't change, actually? Is it that they represent essentially... Oh, you get them when you put in liquidity. So essentially that represents the liquidity that you have put in terms of both elements of each pair, right? Yeah. Okay, perfect. This feels so good. This feels so good, by the way. Sorry. LP tokens represent your proportional share of both tokens you deposit into the pool. When you later redeem those tokens, how does their amount translate into the exact quantities of each token you withdraw? Well, I guess it's just a simple multiplication, right? Why did I get stuck? I guess it's a simple multiplication, right? Okay, I guess what's happening is you have essentially it's a proportion, right? So I guess what happens is a proportion of the supply of LP tokens, and then essentially whatever is left in the reserve, that's what you're taking out. With that ownership picture in place, how does a simple swap alter the reserve ratio and set the execution price for the trade? Well, when you execute a swap, because essentially you're adding supply to one of the sides and you're taking from another, then essentially that the ratio of one token and the other is what defines the price. See this, the ratio, what stops the ratio from changing without limit after repeated swaps in one direction? What stops the ratio from changing without limit? Well, the fact that the proportion defines the price of the next swap. And so essentially it becomes more and more expensive to execute the same swap, naturally. What rule inside the pool ensures the product of the two reserve amounts stays constant through every swap? The product of the two reserve amounts. To be honest, no idea. Quick mental model. Yeah, okay, that's okay. That's all right. The constant product rule is constant. Is the core mathematical rule, so-called constant product formula, right, used by constant product automated market makers. When a trader adds X of one token, the contract calculates the exact amount of the other token to remove, so the new reserves still satisfy these. Okay. The same check or equivalent math happens in the opposite direction. Fees are usually added to the reserves before the invariant is rechecked, so K slowly grows over time as fees accrue to liquidity providers, but the product remains constant within each individual swap. The invariant is what replaces traditional order book. Yeah, what's the question here? Sorry. You're seeing how each swap shifts the ratio, making the next trade in the same direction costlier. What rule inside the pool choose the product to I guess the constant product rule, I guess that's what it wants me to say, right? How does it fix the precise output amount? Well, there's a constant K, right? There's essentially, the rule says one side times the other equals a constant K, and this constant K must always be the same. So if I'm adding to the X side, then I can calculate the Y side. It's a simple calculation. Once you calculate the new reserve, what does the changing Y represent for the person executing the swap? It's what they're getting. It's what they're getting. It's a normal mathematical equation. Like, it's just these. Do I need to copy these? Okay, solving that for these, how much? Okay, so what does the resulting expression reveal about how large an input is needed to get a desired output? It's the price, right? I mean, so essentially the delta is what you are getting. So this is proportional to this K. It's basically, this part goes underneath as a division, and then y is there multiplied. So it's the ratio, it's still the ratio of y over x plus the delta you're adding. I'm not so sure where you're trying to get with these. It's the it's the price. Okay, it is. Give me a second. What determines the price quote the pool will give for an infinitesimally small swap that follows immediately? The immediate block is figuring out why we're looking at the x over y ratio plus delta when thinking about the x price. The y over x ratio. I'm not so sure what it's getting. What is the gap you're trying to help narrow down here? It's quite stubborn with these. Ending reserves. How would you calculate the effective price paid across the whole swap? When you say the whole swap, what do you mean? And why are you talking about the starting and the ending reserves? They always sound like you're wondering why, like you're wondering, you're noticing. I don't like this pattern too much. Give me a second. I need to tweak the. If the reserves move from one pair of values to another during a swap, what single ratio between those two states tells you the actual average price you paid? X over, no, y over x plus the delta of x. Ah, that's stupid. If you're testing the updated x in the denominator. If you instead divide the actual tokens received by the tokens you send, what? That single value, does that give you the whole? What single value does that give you for the whole trade? The tokens you received, the delta y, by the tokens you send. Wait, where was that? Let's take that to a notebook for a second. If I do the tokens I received divided by what I sent, what does this give me here? Very easy. Do this for me, Grok. The trade-off ratio. Interpretation is the effective exchange rate you receive when you send. Yeah. Is lower than the spot price because the trade itself moves the price against you. Exchange rate. So as this delta approximates 0, the ratio approaches the current spot price. I guess that's what's trying to tell me. Okay, so let's think about this. So this is the exchange rate. That's what that's what it is. So from a definition standpoint, the exchange rate is not the same as the price. That's it. How would splitting a large order into smaller trades change the total tokens you receive? How would splitting a large order into smaller trades? This is interesting. How would splitting a large order into smaller trades change the total tokens you receive? And that is probably interesting because these oh yeah, by the way, live testing session. Yeah, I'm both learning and doing a live testing session. Do this every day, man. So how would splitting a large order into smaller trades change the total? That's important because that's probably what these fucking bots do all the time. They do like micro transactions, right? So how would splitting a large order into smaller trade change the total tokens you receive? Okay, so the exchange rate is always less than the spot price, because it's the execution rate. And actually, if it's infinitesimally small, it approaches the spot price. So in theory, splitting a large trade into smaller ones gets you a better exchange rate, doesn't it? Peace. Peace. I mean, fees are added. That's a good question, actually. Where do fees even go? I'll start a new one. Fees increase the pool tokens reserve, slightly shifting the invariant towards a new price ratio post swap. But the fees are, I mean, it is clear to me that the fees then affect the price post swap, but the fees, do they go, in what side of the pair do they go, the fees? Okay, so building on what you just said about splitting large orders into smaller orders fees, what do you recall? Centralized exchange differ from centralized ones and why liquidity matters in that context. I guess K increases, and that means the liquidity pool slowly increases, and so the LP providers are happy. I guess it's proportional. But maybe let me answer your question before. So building on what you said about splitting large orders into smaller trades, what do you recall about how the centralized exchanges differ from centralized ones and why liquidity matters in that context? Well, it's actually it's these. I guess to answer your question here, that's a key difference, because in a centralized exchange, price is determined by demand, right? So there is no price shifting. Beats or asks to the price. Nothing really. Oh, that's a good question. If your buy order clears all the current sell orders, what the price of the remaining shares of your order feel at? I have no fucking idea. In a that's a good point. So for market buy of 500 shares, it feels 110, then 210.50. Okay, that's just a thinking trace. And I'll probably wrap it up here. So I think Or liquidity matters. I think liquidity matters. In your own words, how a simple liquidity pool with two assets functions for price discovery. Yeah, that's interesting actually. This is actually very interesting insights, guys, because in terms of building the bot, right? I think we can mark this one as done. Although I said that that button doesn't work actually for some reason. But we've done, I think we're done with chapter 1, and chapter 2 is going to be these, and then what else we have? Think about what happens to pull balances when a large swap occurs, and how fees incentivize providers. And then we have chapter 4, summarize key elements, and 5, basically example of impermanent loss. Given 50-50 ETH USD pool where ETH price doubles. Okay, we'll do that exercise, I guess. Sketch describe in your own words how a simple liquidity pool with two assets functions. For price discovery, that is interesting. How a simple liquidity pool with two assets functions for price discovery. I don't know for price discovery. Anyway, that's an interesting example. So centralized exchange is a central limit order book, CLOP, with price time priority matching. Sell orders asks are sorted from lowest price to highest. When you submit a buy order, or it's aggressive for a limit that is a larger volume available in the current best ask you order, first fully clears all sell orders at the current best lowest price. Once that level is exhausted, the remaining quantity immediately matches against the next best. If that level is also fully consumed, it continues to the next higher level, and so on and so on. Walking the book, sweeping the book. Each successive fill occurs at the worst price. It's the worst price for you, higher than the original best ask, which creates slippage. Okay. So your average fill price will be higher than the original best ask. So it has a similar effect. Okay, so essentially, if our order clears all that, that's an odd behavior actually, indeed. What's happened here? Why so many questions at once? Anyway, I'm gonna wrap it up here. I think that is actually very useful, because essentially what I've learned today is that that actually the microtransactions make a lot of sense because they because they actually create less of a price. Like it creates a price that is closer to the actual spot price. But indeed, what happens in price in a larger audience central multiple existing bids or asks. Yeah, in a centralized exchange, you end up having a similar effect just because of the fact that not all the buy orders are at the same price. And that's a slippage. And still has not yet explained liquidity's role, express clear confusion on price after clearing orders, so cannot advance. Oh, that's because is that the answer to me saying done? Okay. I expected this to appear as a pop-up, I think. Let me see. With cards or something. I don't know. I don't want to add too many. Because it almost feels like the probes. Yeah, it's okay. It's all good. Cool, cool, cool. I'll stop it now. And wait, actually, what do we have here? Without any order book or matching counterparties. Whatever. I'm gonna keep that for the next session. I'm wrapping it up here. I think that was actually very useful. So we've let's go back to the dashboard. Let's go back to the plan. And let's go back to, yeah. And I think what's cool about these is now essentially, maybe I want to mark those as in progress and not blue. Just a tag. I don't know if it works if I fixed it, but I can ask Helios about my performance so far. So I can ask Helios now, hey, give me a summary of how have I done so far in the last 3 sessions. And actually, that, you know, I think that's a useful exercise to do as well. Although I added this feature a bit later, I'm not so sure if it's documented the first session correctly for this to show up in an interesting way here. Let's see what Helios comes back with. Okay, so you've completed 0 out of 3 sessions. Yeah, they're not completed yet. You see, it says 0 minutes for the first session because we didn't record here, but then the second is already says 42 minutes. The third is 35 minutes. Solid time investment. No dedicated report or transcript is available yet. Core wallet, yeah. You showed insight in liquidity's role in price discovery in order to wrap up several subtopics independently. Areas of growth, there were recurring signals of hesitation and confusion when mixing centralized order book mechanics with the centralized ones. Engagement style confortable jumping ahead and self-directing once you grasp a concept, but it sometimes mix CX and the X terminology, which shows initial recall steps. Slow price and clear improvement within the most recent session, starting with confusion markers and ending with the complete steps on the impermanent laws in pull mechanics. A strong foundational effort. That's nice. I'm not too happy with this it's maybe maybe too verbose. These reports, like I don't know if I yeah, maybe it should be just a bit more concise. But okay. That's good stuff, guys. See you tomorrow.